So with number 1 from chapter 3, section 7, besides sketching the graph, which we're going to use technology to do that, I'm going to ask for relative extrema and points of inflection. And so in the previous sections, they've talked about how to find where those relative extrema are. Finding critical values, we can find where min and maxes occur, or relative mins and maxes. And so we can do that algebraically. So in this one, if we take the first derivative, we have this equation to find the critical values. We set it equal to 0, and that lets us know where our mins and maxes occur. And so this one's not too bad. So we divide by the -3, and then we'll take the square roots of both sides. Whenever you take the square roots of both sides, just remember that it's always plus or minus. People typically forget that. So that means we have two critical values, and that's where min and max can occur. And to find the actual points, we have to plug this in back to our original equation to find out where the points are. Now, to determine if it's the min or the max, we could use that first derivative test or even second derivative test to do that, but I'm going to suggest just graphing it and finding if it's the positive place on this one. That's where just kind of look at it, determine which one's the min and the max. But actually find your point. So if I'm going to look at the 1 over root 3, I have to plug in 1 over root 3 into this equation to find out what y is, because they're looking for points, and they're looking for exact points, so it's not a rounding thing. So on this one, we would have still a negative. It'd be 1 cubed up top, and the square root of 3 cubed would be a 3 root 3 on the bottom, plus a 1 root 3 minus 1. Going to common denominator here, multiply the other side by 3, so that gives me 2 root 3 then minus 1. Negative. Nope, still positive. Let's take that away. Because again, if I multiply this one on 3, times a 3 on top and bottom to get that common denominator, to get a positive 2 root 3, 2 over root 3 minus 1. Oh, but I still have a 3 in the denominator. There we go. So just finding that y value. So my x value would be 1 over root 3, and my y value would be 2 over 3 root 3 minus 1. So that would be the point, and on this one I believe that's where your maximum occurs. And then to find the other point, we would just put the negative 1 over root 3. To find your inflection points, you're taking your second derivative. So if my first derivative is that, if I take the derivative again, I get negative 6x, and that would be it. Set that equal to 0, and so that gives me a big old x equals 0. To find the point, I take this value that I saw when the second derivative equals 0, and I plug it back into my original equation. That one's pretty easy to figure out. That would give me a negative 1 when I let x equal 0. So my inflection point is at 0, negative 1.